Hi everyone, so today let's solve a Leetcode question called path sum. We're given root of binary tree and target sum. We want to return true if we can find a root to leaf path such that adding all values along the path we have the target sum. Note here leaf is a node with no left child and no right child. Okay, now let's check example to help us understand. So maybe use join here. You see here we have target sum equals to 22, right? And then we have to traverse the entire tree to find, okay, it's the path and sum to this 22. So we start with the root here. This is 5, and we traverse down this 4, this is 11, and this 2. So we found, okay, 5 plus 4 plus 11 plus 2, exactly 22. So we return true, indicating we can find such a path. So the sum is 22. Okay, now let's check another example where we cannot find such a path. So in this example 2, let me just join here with different color. You see the target sum here is 5. And let's start with root. If we go in this direction, 1 plus 2, you see is 3, and it's not 5. And if you go the right direction, so use different color, you see you started 1, you traverse down to here, we have 3. So 1 plus 3, you see is 4. It's also not 5. And we traverse all the route to leave possibility, and we have to return false, indicating we cannot find such a path. Okay, in the final example, we have empty tree. The target sum is 0, so there's no way we can finish this. We also have to return false. For this kind of question, an easy way to solve is using depth search path recursion. Well, our idea is to keep deducting the target when we're traversing from top to bottom, and we want to change the remaining values and subtrees. Let me use this tree to explain why. Maybe just join here. Okay, so from the beginning, you see our target is exactly 22, right? Our target sum is 22 from the beginning, and from beginning we have this node called 5. And when we visit each node, the remaining value is 22 minus 5, so it's 17. So change here to 17. Maybe use stick a color here. And now we get target equals 17. And now we want to traverse both right and the left. So to save time, we'll only explain the left because the right scenario is saying you traverse from this 5 to this 4. Okay, we found, okay, this is 4. So our remaining value is 17 minus 4. Okay, so remaining value here is 13, right? Change here to 13. And now we traverse further down from this 4 to this node. So this node is 11. So remaining value is 13 minus 11. So this is 2, right? Okay, so change this to 2. And how can we get this 2 to 0, right? We'll get 0 means target sum is finished. And we check, okay, from left side we have this 7. So 7 is not 2, and we cannot deduct 2 by 7 equals to 0. But in the right path, you see here, you traverse the right path, we can, okay, here exactly 2. So we deduct this 2 by 2, and we get this 0. So this means this path is valid in our searching. Okay, now with this example here, you must give intuition also to solve this problem. Now let's dive into the coding part. Well, first, let's try the general framework for solving this type of question. For solving this type of question, we need the result array. So it will be empty result array to restore the true and false for a specific path. And now we call help function, which I will write later. So help function should have the root, should have the target sum, and should have a result array. Finally, return the result array. The main function finished. After this main function, let's think about how to define help function. Well, the helper function will have all these variables. And the first thing is to filter out the corner cases where I have no root. If that case, we immediately return null. And the second scenario is that we will check the leaf node. So if leaf node and it match the target sum, then we have to append the true to the result. And then we iterate the left subtree and right subtree recursively, the finish. So with no roots, we return none. Okay, you found the div because we know a leaf node is a node without left child, right child. So root of left and root of right does not exist. And found okay, the leaf node has value equals argosum. This means we have finished this pass successfully. So root of L equals target sum. And we want to append true to result indicating we can finish this pass successfully. Now call helper function, passing root or left, check its left child. The target sum will be target sum minus root of L because we have use up root of L in this iteration. And the result array should be the same. Now let's change here. So slide change this to root of right. And let me summarize the result to see it works. Okay, you see the time capacity, memory usage efficient is not bad, right? Now overall, I think the coding part is easy to understand. Okay, if you like this video, please subscribe to my channel, and I'll see you next time. Thank you.